Welcome back. And now let's take a look at a different problem. What if I wanted to find the missing sides on what is called a 30, 60, 90 triangle, and I only knew one side? Well, at this point, we would not be able to fill in anything else because different angles produce different sides. And with only one side in a right triangle, we could not use the Pythagorean theorem. So we need to develop some kind of relationship between the sides in this type of right triangle. So let's look at the derivation and then we'll do some examples to see how this works. So if I started with an equiangular equilateral triangle, and to make it easy, let's make every side 1. What I could do to derive a 30, 60, 90 triangle is I could construct a perpendicular bisector. Okay, that's 90 degrees. And I could realize that that would cut this side in half. This would be a half. And I could look for the height on this triangle. So let's just sort of go over here and let's redraw that a little bit bigger. So that's 30. This is 90, this is 60, this is 1/2, this was 1, and we're looking for h. And I could use the Pythagorean theorem, right? I could say that a squared plus b squared equals c squared. And a squared in this case would be 1/2 squared plus h squared equals 1 squared. 1/2 squared is 1/4. And I'm going to make this 1 squared 4/4 so that when I subtract 1/4 from both sides, I get h squared equals 3/4. Taking the square root of both sides, h equals the square root of 3/2. And remember, when I take the square root of a fraction, I take the square root of the numerator and the denominator separately. So it looks like h is equal to root 3/2. And this is an interesting relationship. What we're going to notice is that the smallest side is always across from the smallest angle. Okay, so 1/2 is my small side. The medium side is going to be across from my medium angle. So the root 3/2 is my medium side. And of course, the large side is going to be across from my large angle. So the hypotenuse is my large side. And if we notice the relationship between the sides, going from small to large, how do I get from 1/2 to 1? It looks like I just multiply by 2, right? Similarly, going from small to medium, it looks like I'm multiplying by the square root of 3, because really 1/2 times the square root of 3/1 equals the square root of 3/2. So the relationship seems to be small to large, multiply by 2, small to medium, multiply by the square root of 3. So let's formalize that in the next page. If you look in the notes, this relationship will always hold in a 30, 60, 90 triangle. Again, you're going to have your smallest side across from the smallest angle. Your medium side will be across from your medium size angle. And your large side will be across from your largest angle. And this relationship will always hold. Going from small to large, multiply by 2. Conversely, going from large to small, I would divide by 2. Going from small to medium, multiply by the square root of 3. And conversely, going from medium to small, divide by the square root of 3.